Let's look at some different types of problems that use our trig function ratios and some of the identities. One of the first things we talked about that involved trig ratios was where we had a point on the terminal side of an angle and we found values of the trig functions for that angle. In this case, we're just trying to find the values for sine of theta and cotangent of theta. And remember, in most of these problems, it's going to help you to draw the picture. I'm drawing a graph and I'm going to plot this point on the graph. For one thing, that helps me know what quadrant it's in. This point is going to be in the fourth quadrant. So my angle, if I'm trying to draw an angle with positive measure, my angle theta would be that one. This problem does not ask me to find the measure of angle theta. It's just asking for the trig function values. So to do this, I need to know my x, my y, and my r. Since this point was 1, -6, that means my x is 1, my y is -6, and then to find my r, I'm using this formula, plugging in my x and my y. That gives me the square root of 37 for r. Now here's where I need to know those trig function ratios with x, y, and r. Sine of theta is y over r. In this case, that would be -6 over the square root of 37. For this test, I don't care if you rationalize denominators, so it's perfectly fine if you leave your answer like this. I'm not going to grade you on whether you can rationalize denominators or not. So we've got that answer, and then for cotangent of theta, if you don't want to memorize the ratios for the 3 reciprocal functions, you can just memorize the ones for the 3 main functions and then flip them over. So remember, this is the reciprocal of tangent, and tangent is y over x. So y over x would be -6 over 1. Then if we're trying to do the reciprocal of that, we would just flip it over. That gives us cotangent of theta is -1 over 6. For this one, we've got a value for cosecant and we're trying to find sine. One of the things you'll need to do for this test is figure out which identity or which formula to use. That depends on what you're given in the problem and what you're trying to find. In this, you're given the value for cosecant and you're trying to find sine. If you're looking at some of those identities, the one that relates these two functions specifically is one of the reciprocal identities, and that is that sine is 1 over cosecant. Or you could think of it that cosecant is 1 over sine. Either way, these two are reciprocals of each other, so if you have one of them, to get the other one, you just flip the value over. So to get sine from this, we're going to just take this fraction and flip it over. That gives us sine of theta equals 2/5. And that's all we have to do for that one. In this one, again, we're going to go back and look at our identities, see which one just involves cosine and sine. That would be our first Pythagorean identity. That says that sine squared plus cosine squared equals 1. Now let's rewrite this with our exponents on the outside of parentheses. What we want to do now is plug in the value that we're given for sine of theta, and then we want to solve this for cosine of theta. If I plug in -4/5 for sine of theta, that gives me 16 over 25. Now I'm going to subtract 16 over 25 from each side so that I've got cosine theta squared on this side. That would give me 9 over 25 on that side. I'm going to take the square root of each side, and at this point I need to figure out if I want a negative value or a positive value for cosine. I'm looking back at the problem. It says that theta is in quadrant 3, and if you remember, all students take calculus. Quadrant 3, only tangent is positive. That means both sine and cosine are negative. So here I want to take the negative square root. So if I take the square root of 9 over 25, I'd get 3/5. I'm going to take the negative value of that for my answer. Okay, one more. This one involves secant and tangent. If you look through your identities, there is one that involves just secant and tangent. That one says that tangent squared theta plus 1 equals secant squared theta. This is another one of the Pythagorean identities. I'm going to rewrite this with the exponents on the outside again. I'm going to substitute in my value for tangent of theta here. If I square negative 7/4, that gives me 49 over 16. 49 over 16 plus 1, if I get a common denominator and add those two, that's going to give me 65 over 16. Here I want to take the square root of both sides. Again, I need to look at the quadrant to find out whether secant would be positive or negative. This says theta is in quadrant 4. In that quadrant, cosine is positive. Secant is the reciprocal of cosine, so secant is also positive. So when I do my square root, I'm going to take the positive square root. On the top, I end up with the square root of 65. On the bottom, the square root of 16 is 4. Here's another one that's giving me the value for tangent of theta and asking me to find sine of theta. For this one, there isn't an identity that directly relates these two that doesn't have another function involved. What I can do in a situation like this is take one or the other of these and look at its reciprocal and see if I can find an identity that relates the reciprocal. If I look at the reciprocal of sine, that's cosecant. There's not something that relates cosecant and tangent. But if I also look at the reciprocal of tangent, that's cotangent. There is an identity that relates cosecant and cotangent. And that one is that cotangent squared theta plus 1 equals cosecant squared theta. That means I'm going to have to look at the reciprocals of both of these. So first of all, if tangent of theta is 1/4, the reciprocal, cotangent of theta, is going to be 4 over 1 or just 4. I can substitute my 4 in here for cotangent of theta. That gives me 4 squared is 16 plus 1 is 17. Now to figure out whether cosecant is going to be positive or negative, I have to look at the information in the problem. This problem just tells me that cosine of theta is positive. That says that my angle either has to be in the first quadrant or the fourth quadrant. Cosine of theta is positive in these two quadrants. Tangent of theta is positive, since we know it's a positive 1/4. That happens in quadrant 1 or quadrant 3. So where both of these are positive is quadrant 1. That tells me here that my cosecant also has to be positive. Since we're in quadrant 1, I'm taking the positive square root, and that gives me the positive square root of 17. What I was trying to find was the sine of theta, so now I need to take this value and flip it over to get sine of theta. For this problem, again, we want to look at what kind of identity relates secant and cosecant. If you even think about the names of those are cofunctions because we have secant and cosecant. There are a couple different ways to think about this. This says that the two angles inside of these two functions have to be complementary. They have to add up to 90 degrees. Or we can also use one of the actual identities that says that secant of theta is equal to cosecant of 90 minus theta. Either way you do this one is fine. I'm going to do it by just taking the two expressions, adding them, and making my total 90 degrees. Then I'm going to solve this for theta. So I'm combining my like terms. That gives me 7 theta, and minus 18 plus 27 gives me 9. And to solve this, I want to divide both sides by 7. This problem didn't tell us how many decimal places to round to. So I'm just going to round it to 1 decimal place, which gives me 11.6 degrees. Finally, for this one, we have a right triangle, and we've got an angle measure. Be careful with these that you label the angles in the correct place. So this is angle B here. That's my 52 degrees. And I've got side A. Remember, the side letter and the angle are always across from each other. So this is A, which is 36.0 centimeters. And I'm trying to find the lengths of sides B and C. For this, since I only have the length for one side, I'm going to have to use a trig ratio to find the other two sides. If I'm going from angle B, then side B is the opposite. And the one that I do have, the A, is the adjacent. The trig ratio that involves opposite and adjacent is tangent. Tangent of 52 degrees is opposite over adjacent, which would be B over A, or B over 36. I want to solve this for B. I can cross multiply again, so I would have tangent of 52 degrees times 36. And on the other side of the equation, I would have 1 times B. For this one, I'm just going to multiply this on my calculator. And this says to round to 1 decimal place. That's going to give me 46.1 centimeters for B. I also need to find C. At this point, I could either use the Pythagorean theorem, since I have a right triangle, or I could use another trig ratio. The trig ratio that would involve the hypotenuse and the adjacent would be cosine. So that would be adjacent over hypotenuse, and then I could solve this one for C by cross multiplying again. This time I end up having to divide both sides by the cosine of 52 degrees. I'm going to do that all in one step in my calculator so that I don't have to worry about rounding error. When I round that answer to 1 decimal place, it gives me 58.5 centimeters. So that's my value for C.